Welcome. This video is going to talk about mixtures and how they differ from what we know as substances. So far this year, we've mostly talked about substances, and those are either elements made up of just one kind of atom or compounds made up of more than one kind of atom that are chemically connected to each other. So now mixtures are forms of matter that are a combination of two or more substances that are just mixed with each other. They come in contact with each other, but each substance keeps its basic identity. No chemical bonds form. So most forms of matter that you work with in your day-to-day lives are actually mixtures. So physical properties like density and boiling point are going to be affected, but the chemical properties are not. So this would be like when you dissolve salt in water, when you dissolve anything. That's just a mixture. Two kinds of mixtures are homogeneous or homogeneous and heterogeneous. And homogeneous means just what it sounds like. It's the same throughout or mixed evenly. So if you took a sample from two different areas of your mixture, they would be identical, even under a microscope. But heterogeneous, they're not evenly mixed. And so if you took two different samples, they very likely would be different. And so these are either colloids or suspensions, whereas homogeneous are what we call solutions. So here's a little flow chart. You may want to take a screenshot of this. And I noticed that I'm missing a word here, so I'm just going to go ahead and sneak suspensions in here. And then you might want to take your screenshot. But you might want to take a screenshot of this just to refer back to. So matter is anything that has mass and takes up space. We've talked a lot about substances. They have a definite composition. You can write a chemical formula for them, so it's things like elements and compounds. But now we have mixtures, which have this variable composition, so we can't write a formula for it. Even a homogeneous mixture does not get a formula because salt water, even though it's homogeneous when you make it, you can have a lot of salt or a little salt in there. So mixtures have no formula. So how do you know if you have a solution, a colloid, or a suspension? There's a couple things we can look at. And one of those is something called the Tyndall effect. And the Tyndall effect is the scattering of light by particles in a mixture. So if the solute is able to scatter light, that will help you identify whether you have a solution, a colloid, or suspension. And this scattering of light is caused by particles suspended in either a colloid or suspension because they are big enough to scatter the light, that the light doesn't just get around it. You remember light wave moves as a wave, so if the particles are small enough like a solution, then the light just goes around those particles and we see no Tyndall effect. So examples of this are when you see lasers during a light show, they put a lot of mist or particles in the air to help you see the laser. Driving in the fog or in heavy snow, when you see the sun's rays through a cloud, those are all everyday examples of the Tyndall effect. On this side, I've got an example of someone demonstrating the Tyndall effect, and you see there's two liquids. They both look fairly clear, although if you look carefully, the one on the left does appear a little bit cloudy. And on the far right, you see somebody shining a laser through, and you don't see the laser in the liquid on the right at all, although you can see it on the edges of the glass, but not in the liquid itself, but in the liquid on the left, we definitely see the laser passing through. So that helps us to realize that the mixture on the right has to be a solution because only solutions lack the Tyndall effect. The laser beam can't be seen. But the mixture on the left does scatter the light, so it's either a colloid or a suspension. Now, I went ahead and put on my notes, it's a colloid. So how did I know it was a colloid instead of a suspension? Well, let's look a little more carefully at how each is defined. A solution has to be homogeneous, means it's the same throughout. Now, unless you have a microscope, you don't necessarily know that it's homogeneous or not. They're going to be clear. Now, remember, clear doesn't mean it doesn't have a color. It just means it's transparent. So like orange soda is clear, whereas orange juice is not clear. Solutions do not settle. So if you leave it standing for a while, orange soda isn't going to separate into layers like orange juice will. And you can't filter it. Even salt water, you can't filter the salt back out. You have to evaporate the water off. And then finally, they don't exhibit the Tyndall effect. And the reason why these properties are true for solutions is because they contain the smallest solute particles with an atomic size less than 1 nanometer. So let's just say small. So again, examples would be salt water, soda, If you mix Kool-Aid with sugar, the sugar gets evenly spread throughout, too small to be filtered or to exhibit the Tyndall effect. But colloids are heterogeneous. They're not the same throughout. They tend to have a cloudy appearance. Now, if a colloid is very weak, if there's very little of the solute in there, you may think it looks clear. You may think it's a solution. But if it's a colloid, you will see the Tyndall effect. But again, there'll be no settling or filtering. The particles are bigger than an atom, so they're between 1 and 1,000 nanometers, but they're not big enough to filter or big enough and heavy enough to settle out. But they are big enough to scatter light and give you the Tyndall effect. And some examples are milk. Even just a drop of milk in an entire glass of water is going to cloud it up and give you that Tyndall effect. Mayonnaise is a very thick colloid. Motor oil, blood, those are all colloids. Suspensions are also heterogeneous, also going to be cloudy, but now they are going to settle over time and separate into 2 or more layers. And these particles are big enough to be filtered out, and they definitely exhibit the Tyndall effect, although sometimes the particles are so big the light doesn't pass through at all. It starts through and it gets totally scattered back the direction it was coming from. So suspensions contain very large particles compared to the other dissolved solutes. Are going to be larger than 1,000 nanometers. These could be things like muddy water, orange juice. Aerosols are anything you have to shake before you spray, any kind of spray paint, hairspray, those types of things that you have to shake up first. If your directions say shake well before using, that's a pretty good hint it's a suspension. So my final question, or my final slide here, is saying list the steps you would use to decide if a mixture was a solution, a colloid, or a suspension. So if you think about this for a bit, you can do some visual things, but mixtures can be separated physically. So really these are pretty simple tests that you could do. And what I would do is I would first look to see, is it cloudy? And if you say no, it's not cloudy, then it's most likely a solution. I'm going to say probably because you can have very weak colloids that appear to be clear or not cloudy, and they turn out to be colloids. So it's probably a solution. If it's yes, it is cloudy, then I know it's not a solution. It's either a colloid or a suspension. So back over to the left side, if it's not cloudy, I think it's a solution. How can I know for sure if it's a solution or not? Try the Tyndall effect. Shine a laser or a bright light through it. I should have another F there with my effect. And if there's a Tyndall effect, it's actually a colloid. And if there's no Tyndall effect, then I've confirmed that I've got a solution. For my cloudy substances, cloudy mixtures I should say, to decide if it's a colloid or a suspension, you can do the Tyndall effect if you want, but they're both going to show the Tyndall effect, and the fact that it's cloudy lets you know you're going to see the Tyndall effect. So really what you could try instead is you can either wait for it to settle, or you can go ahead and filter it. If it either settles or it filters, you can filter something out of it, you have a suspension. But if it doesn't separate into layers or you can't filter it out, you have a colloid. So you can visually look at it, make a decision if it's cloudy or not, and based on that, perform just one simple test, either the Tyndall effect or filtering or just waiting for it to settle, and decide what kind of mixture you have.